from Olinka with Hames Chemistry, and today we're going to do the last lesson for our online school. We'll learn how to balance equations. Today we're going to learn about basic types of reactions. Atoms don't randomly combine to form substances. There is like 5 basic patterns and 5 basic ways that they do it. So we're going to cover synthesis, decomposition, single replacement, double replacement, and combustion.
Oh, look at me. I'm all alone, just a single element. I'm bored. Oh, look. My sister is all alone and bored too. Let's combine. Look at us. We are not single anymore. We are chemically combined.
As Karina and Kira demonstrated you in a synthesis reaction, what you're going to do, you're going to start with 2 reactants. So reactant 1, which is H2, reactant 2, which is O2. Your reactants are going to combine and make one single product. Over here is H2O, and when you combine product, that's your product. Another scenario, you have a different equation. You have Na, which is sodium. That's a single element. That's your reactant number 1 plus Cl, reactant number 2. When they combine, they make sodium chloride. Two elements chemically combine together.
Element, you're heavy. Rude. I'm breaking up with you.
Well, now we're single elements again. We decompose.
Okay, so decomposition is backwards. Instead of having 2 reactants, we're only going to have 1 reactant, and that reactant is going to separate into simpler substances. So over here, this is my reactant, this is my substance, then you're going to have a yield error immediately, and what's going to happen, you're going to have 2 products. So KCl is one product, O2, that's the next product. Another example of decomposition is zinc sulfide decomposes into zinc and sulfur. Look, make sure you have 1 reactant, yield error right away, and then you have 2 products. That's how you know that it's decomposition, which is the split. One important thing is not to confuse synthesis and decomposition. So over here, I'm showing you the difference. When you have synthesis, you have 2 reactants that make only 1 product. In decomposition, it's absolutely backwards. You have a reactant, and reactant is going to split into 2 products. So synthesis, only 1 product. Decomposition, only 1 reactant.
Look at me and my turtle. We're together and we're chemically combined. Look at my sister. She's a single element and she's alone. Ugh. Let's go, little boy. Here. Now she's chemically combined and they're together and I'm all alone. I've been replaced.
Next type is a single replacement, when element in a compound is being replaced. So those are the things to watch for. You're always going to start as an element and a compound on your reactant side. So watch over here. This is your element, magnesium. This is how it's single. Your compound is HCl because it's made of 2 elements. What's going to happen is Mg going to replace H. So look over here. Mg goes with Cl to form a compound plus hydrogen as a single element. So there is always 1 element that is going to be replaced. Look at another example. Make sure you always have compound and element on both sides, reactants and product. So as you can see, copper is my element, AlCl3 is my compound. On my reactant side, aluminum is the element, CuCl2, that's my compound. Aluminum replaces copper, single element replacement.
Look at us. We both are chemically combined with our turtles and none of us are single.
You have my turtle. Let's switch. Look at us. Now we're chemically combined with the right turtle.
And that's how you do double replacements.
Okay, as was demonstrated by Karina and Kira, we are going to do double replacement. So in this reaction, nobody's going to be left crying, and this is just going to be a switch. So the things to look for, you will always have two reactants and two products. Your reactants and products will always be compounds. Compound, 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 and compound. You will not have no single elements. So look over here. You had Pb, NO3, and that's your first compound, and then Ki, that's your second compound. What happened? K and NO3 traded places, and this is your two new compound. That's why it's called double replacement. I'm going to give you single versus double replacement, not to mess it up. Remember, when you have a single replacement, you have to have your element as a reactant and as a product. When you have a double replacement, you're not going to have just an element. All the substances, all reactants and products will be compound. And that's how you know. In double replacement, no elements. In single replacement, you need to have that element. And the other one will be compound. Okay, the last type of equation, and probably the most complicated one, is called combustion. When you have combustion, it's a very specific reaction. You are going to have CO2 and H2O as a product. Make sure you have both of them. If you only have one, that's not combustion. So this reaction is combustion because you have a hydrocarbon, because it's made of carbon and hydrogen, reacts with oxygen gas, and look what your products are. CO2 and H2O. That's what makes it a combustion. This example is combustion as well because look at your product. CO2 and H2O. It has to be both of them. Because look, sometimes you're going to get this. Some substances react, you have H2O, but you don't have a CO2. So this thing is not combustion.
This is what you're going to get on your assignment. And you'll get equations like this, and you have to identify what type it is. So now I'm going to try. I think this one is synthesis. No, wait, I think this one's synthesis because they are combining, because there's a plus sign, so they're going to combine. And I think this one is decomposure because they're together here and then they split over here.
Okay, so Karina said that this is decomposition, which is, she is right. Because look, you have only one reactant, and reactant splits and gives you two products. So that's how decomposition looks. The bottom one is synthesis, as you can see, it's completely backwards. You have two reactants, and they combine to make one product, which is CO2. So she did good.
So now I'm going to guess one of these equations.
Wait, let me try. This is double replacement. I don't know. I'm out of here.
Anyway, so I think this first one is double replacement because right here you see the equation over here, and BR is over here, but then BR is over here, and then CL is here, and CL comes over here. So I think it's double replacement. And this bottom one right here, I think it's combustion because it doesn't look like any of the other ones, but I'm not sure.
I think Karina did pretty good. However, this is a replacement, but it's not double replacement. It's a single replacement because I told you what to watch for. This is not a compound, this is element. Single element, ignore this too. It is just chlorine. What chlorine does, it takes place of this Br, and look what you have over here. Cl instead of Br, and Br is single. So this is single replacement. Bottom one, she actually guessed right. It is combustion because it doesn't look like any of it, but this is what's very important for combustion. As a product, which is these two substances, you only going to have CO2, coefficient can be different, and H2O, coefficient can be different. That's what we have, that's why it's combustion.
I'm gonna do it. I think they're both double replacements because I see a lot of things and nothing is single.
I'm going to tell you this, Kira was right. Both of these things are double replacement, and this is how you know. She said she sees a lot of everything and nothing is single. She is correct. All she sees is compound. This is a compound because it's made of Fe and O. This is a compound H and O, three different elements. Compound again, three different elements, and compound again of two different elements. If you look at the bottom, we see the repetition of the same pattern. Everything that we see here is a compound and no single elements. So, therefore, both of them double replacement. I hope this information helped you. Have fun doing your assignment.
This was the last lesson for online school. Thank God.
We are out of your lives. Make sure to like and subscribe. Bye.
Kids, by the way, I send it out to you. Use it. It will help you a lot. If you pass this, then you can safely enjoy your summer. Bye.